Alright, let's talk about the single most exciting and often most expensive component you'll ever slot into a PC motherboard, the graphics card, or GPU for short. Why all the fuss? Well, think of your computer's main processor, the CPU, as the brilliant, logical brain. It's a master of spreadsheets, calculations, and running your operating system. But when it comes to creating the stunning, lifelike visuals you see in modern video games or rendering a complex 3D model, the CPU just can't keep up. It's like asking a world-class mathematician to paint the Mona Lisa. They could probably figure it out eventually, but it wouldn't be pretty or fast. That's where the GPU comes in. It's the artistic soul of your machine, a specialized powerhouse designed to do one thing exceptionally well: process massive amounts of visual data all at once. It takes the game's code and translates it into the millions of pixels that make up the image on your screen, updating them dozens or even hundreds of times every second. A powerful GPU means smoother gameplay, higher resolutions, and the ability to turn on all those fancy graphical settings like ray tracing that make light and shadows behave just like they do in the real world. It's the difference between a choppy, low-res mess and a buttery smooth, immersive experience that pulls you right into the game. But it's not just for gamers anymore. If you're a video editor, So how do you even begin to compare two different generations of graphics cards? It's easy to get lost in a sea of acronyms and numbers like CUDA cores, teraflops, memory bandwidth. Let's simplify it. Think of CUDA cores as the workers on a factory assembly line. The more workers you have, the more tasks you can handle at once, which generally means better performance. The RTX 40 series, led by the mighty RTX 4090, already packed a staggering number of these cores. The RTX 50 series is set to take this further, using a more advanced manufacturing process to cram even more cores onto the silicon, promising a significant jump in raw processing power. Next up is VRAM, or Video Random Access Memory. This is your GPU's dedicated ultra-fast memory. It's where the card stores high-resolution textures, 3D models, and other visual assets it needs to access instantly. If you run out of VRAM, the card starts pulling from slower system RAM, causing stutters and big performance drops. The RTX 40 series was generous with VRAM. Cards like the 4090 boasted 24 GB. The RTX 50 series is expected to match or increase that and use a newer, faster memory standard called GDDR7. That lets the GPU access data even quicker, crucial for 4K and beyond. Power efficiency is the unsung hero of GPU design. It's not just about your electricity bill, it's about heat. A more efficient card delivers more performance without turning your PC into an oven. The Blackwell architecture in the RTX 50 series is expected to continue that trend. Let's get to the main event for most people: gaming. How does this generational leap translate into actual frame rates? RTX 40 series, the RTX 4070, became the gold standard for high refresh 1440p. The RTX 4080 made smooth 4K gaming achievable for many. The RTX 4090 pushed 4K even further. In Cyberpunk 2077, with everything cranked, an RTX 4080 could push past 60 FPS at 4K, especially with DLSS enabled. That was a massive achievement, visually stunning and responsive. The 40 series set a very high bar for premium gaming. Now enter the RTX 50 series. This isn't a small bump. It's a significant generational leap. Imagine the same Cyberpunk scenario, where the RTX 4080 gave you 60-70 FPS. A projected RTX 5080 could push 100-120 FPS at the same settings. This completely changes the game. 4K high refresh rate gaming becomes the new standard. You might not need DLSS performance mode, you could use quality mode for better fidelity. This performance uplift has a cascading effect. For competitive gamers, Valorant. For competitive gamers, Apex Legends. Pushing 360Hz monitors or even 480Hz monitors. All at 1440p for the ultimate response time edge. For single-player fans, 4K with full ray tracing or path tracing becomes a no-compromise option. While gaming grabs the headlines, the impact of a new GPU generation on creative and professional workflows is arguably even more profound. For video editors working in software like DaVinci Resolve or Adobe Premiere Pro, time is money and render time is lost time. The RTX 40 series was already a beast in this department, using its powerful CUDA cores and dedicated video encoders, NVENC, to dramatically accelerate video exports. A complex 10-minute 4K project with color grading and effects that might take 15 minutes to render on an older GPU could be finished in under 5 minutes on an RTX 4080. It was a massive quality-of-life improvement for content creators. The RTX 50 series is poised to blow those numbers out of the water. With more CUDA cores and, crucially, the faster GDDR7 memory, the entire video editing pipeline gets a boost. The faster memory means smoother playback of multi-layer 4K and even 8K timelines with effects applied in real time without dropping frames. That same 10-minute 4K project could be rendered in as little as 2 to 3 minutes on an equivalent RTX 5080. For a professional who renders multiple videos a day, this saves hours of waiting each week. Let's talk about the elephant in the room: price. A top-of-the-line graphics card can cost as much as an entire mid-range PC. When the RTX 40 series launched, it came with some hefty price tags. RTX 4090, MSRP $1,599. RTX 4080, MSRP $1,199. Enthusiast-grade prices. Enthusiast-grade performance. RTX 4070, $599. RTX 4060, $299. Mainstream entry points into Ada Lovelace. Now the RTX 50 series is arriving. RTX 5090, expected premium launch price, likely around $1,600 or more. RTX 5080, likely similar to the 4080's launch price. Mid-range is the real value. RTX 5070, likely $600 to $700. Projected to rival or exceed RTX 4080 performance. Classic generational uplift. So, who should be buying what? Budget gamers and creators should consider RTX 40 cards. Retailers will clear out old RTX 40 stock. These cards remain very capable for years, especially at 1080p and 1440p. Beyond just being faster, each new GPU generation introduces new features and technologies that redefine what's possible. The RTX 40 series' big trick was DLSS 3 with frame generation. This was a revolutionary AI-powered feature. Unlike DLSS 2, which upscaled lower-resolution pixels, DLSS 3 could generate entirely new frames and insert them between rendered ones. This dramatically boosted frame rates, making super-smooth ray-traced gameplay possible. It was a game-changer, but it added a small input latency, so it was best for single-player games. The RTX 50 series will debut DLSS 4. We expect a significant refinement. It will leverage Blackwell's more powerful AI hardware to improve upscaling and frame generation, reduce visual artifacts, and make generated frames nearly indistinguishable. NVIDIA is also working to reduce latency. So, after all that, we come back to the big question: RTX 40 series or RTX 50 series? The truth is, there's no single best choice for everyone. Who you are, what your budget is, what your PC needs to do. It's about finding the point where price and performance intersect perfectly for you. There is absolutely nothing wrong with buying a 40 series card today. They are phenomenal pieces of technology and will continue to do so for a long time. If you're a budget-conscious gamer or someone looking to upgrade from a much older card, the RTX 40 series is your champion. As the 50 series hits the shelves, you are going to see some incredible deals on cards like the RTX 4060 Ti and RTX 4070, which can be found for well under its original MSRP, will give you an absolutely spectacular 1440p gaming experience. It's a massive upgrade that you can enjoy right now without waiting, and it represents tremendous value for your money. However, if you're an enthusiast building a new top-tier rig, or a creative professional whose income depends on render times and workflow speed, the RTX 50 series is the clear winner and is worth waiting for. The investment will pay for itself in smoother 4K gaming, faster project turnarounds,